Hi guys. So first, I'm sorry I'm not there today. We talked about this. It's my jury duty day. It's kind of a legal obligation, so I can't get out of that. I'd much rather be at school because unfortunately, the stuff that we're going to show you today, if I was there, it would honestly probably be a lot easier. Okay. Um, so just kind of follow along. We'll get you the formulas. Just like everything else, the more you use it, the more comfortable you'll be. You will not have to memorize these formulas. So just keep that in mind. Okay. So the last couple of days we've been doing these including today, we've been writing these hypotheses, which are statements that we're trying to either reject something that's happening or failing to reject. Okay. So today we're going to mathematically test the null hypothesis. Okay. So in order to do that, we're going to first find what's called the test statistic. Now I'm just going to write it over here and go over the lines. So the test statistic. Okay. In that case, all right, it has all about what you're given in the problem. So sometimes we'll talk about proportions, which is p hat, right? And that's the yeses or nos, or mean, which we often denote with mu or x bar, and standard deviation, which is sigma, or sometimes it's s, depending on what's known. Okay, so I'm going to drag over the formulas just because that way they're a little bit neater. Okay, so here's the formula for the first one about proportion. And now that is, ready? And I wish it would drag over easier. Okay, and that is this formula right here. So we take a look. All right, it is z. It's the same type of z-score, right? We've been following z about where it falls on the curves, right? P hat is the proportion that is yes or no. Okay, so for example, like whatever the small sample says, they're yeses. So like if 11% said yes, then the 11 would go there. Minus, this is the population proportion. So for example, if there's a baby born, it has a 50-50 shot of being male or female, right? Boy, girl. Okay, so it depends on what kind of the problem is, but in that case it'd be 0.5 here. And then this would be 0.5 and Q would be 0.5 because it's the opposite. They have to add to 100%. And it's over N, which is the sample size. Okay, so all of these letters we've worked with before. And we're going to see these equations in action. Okay, but it's just understanding what does the problem say, and how can we use them and plug them in, because the calculation piece, once you get used to the calculator buttons, it's not that big of a deal. Okay, so the next one, there are actually two formulas, and it's based on what is known and what is not. So there are going to be some problems where we don't know the standard deviation, or sometimes we will, and we'll talk about these more. So let me drag that one in. Okay, so this first one, now why is it not? Oh, it's because I'm still my mouse. Let me drag it in. Boom. Okay, so if we take a look, yeah, this looks complicated. We're going to talk about the T1 later, but let's focus on the Z for now. Okay, this would be the sample mean, so like the average of the small people that you asked minus the mean that we're assuming. So chances are that's what we're talking about in the null hypothesis, divided by the standard deviation over the square root of n. Now, I would type this into the calculator first, get an answer, and then plug it into the formula. Okay, so let me get rid of all my markings here, and then we'll scroll down and give you the last one. Okay, so the last one, the standard deviation for test statistic, would be this one, which is coming over now. Now, this is going to have a fancy letter. It's going to look like an italicized X. We pronounce that as chi. Okay. Now, as soon as I drag it in, I got to click in the correct spot. So I apologize for that. It's just because my handwriting, it would not be as clean as these. All right. So chi squared is equal to the population size minus 1 times the population standard deviation. So there's different. Like that's the big group versus the small group divided by the standard deviation on the bottom. Okay. So 3 formulas. Technically it's 4, but we rarely will use that T one. Okay. You do not have to memorize these again, but let's go through and let's work our way through one whole example. Okay. So we have a fertility doctor. Okay. So couples are trying to have children, and they have a small test of their new methods that are trying to have a baby girl. Okay, so if we're talking about this, the null hypothesis is that your proportion should be equal to zero point 0.5. If we think about that, boy, girl, when they're born, 50-50 shot. That's kind of like the standard thing. However, our alternative hypothesis is that this new method, our proportion will be bigger than 50%. Okay. So we have to figure out what the heck we're given. And in this case, this stuff right here tells us we have a small survey. P hat is equal to 13 out of 14 trials because 13 girls and 14. So 13 divided by 14 is equal to 0.928. Okay, so let's figure out which formula we're going to use. All right, so if I go up here, we scroll up, we're definitely going to use the proportion one, and I'm going to copy and paste that down bottom so we can use it. Okay, so if we take a look, I'm going to scroll down. I'm going to put it over here just so we can see it a little bit better. All right, so let's plug it in. Let's see what we get. Our z-score is equal to 0.928 minus 0.50 all over square root of 0.50 times 0.50 all over. The sample size was 14. Okay, so there's all the numbers plugged in. You throw it in the calculator, and our z comes out to be, it's actually down below, so let me scroll down just so I can write the correct decimal place. Z is 3.21. Okay, and so that's how you calculate that. Now, if we look at this picture, okay, it's about understanding what's happening. And this curve, right, Z is 0, and we have it on a scale of -1, -2, -3 to +1, +2, +3, so on and so forth. Okay, anything within 2 would be quote unquote usual. But since that this 3 number is way over here beyond 1 and 2, it's in this red zone, we are actually going to reject the null hypothesis. In this case, since it falls in the red zone, we can say, hey, the sample size shows that, yeah, those methods might have done something to help more baby girls. Okay. The idea is, guys, is you're given a problem, you got to come up with a couple statements, and then you're going to mathematically test that. Okay. So take a look at that homework I'm leaving you for today. I'll have an answer key up, and then I'll gladly answer any questions when we get back.